All right. Back to Learn You Haskell for Great Good. Today we're looking at files and streams, eh? Alright. GetChar is an I/O action that reads a single character from the terminal. We learned about that last time, yeah. GetLine is an I/O action that reads a line from a terminal. Okay, these two are pretty straightforward, and most programming languages have some function or statements that are parallel to them. Sure. But now let's meet getContents. GetContents is an I/O action that reads everything from the standard input until it encounters an end-of-file character. Right, so getContents it means that we can pipe stuff into our program, right? That's our getContents. Its type is getContents IO string. What's cool about getContents is that it does lazy IO. When we do foo and then getContents, it doesn't read all the input data, store it in memory, and then bind it to foo. No, it's lazy. It'll say, yeah, I'll read that input from the terminal later as we go along when I really need it. That sounds interesting. GetContents is really useful when we're piping the output from one program to the input of our program. Yeah, exactly. In case you don't know how piping works in a Unix system, here's a quick primer. Let's make a text file that contains the following little haiku. Right. This thing I know how to do, yeah. I mean, if you don't, well, he'll tell us, right? So just have this text in a text file, yeah. I'm a little teapot. What's with that airplane food, huh? It's so small, tasteless. I mean, it's not the worst haiku I've read, but it's not far off. Oh wow, yeah, the haiku sucks. What of it? If anyone knows of any good haiku tutorials, let me know. I did that in Python once. I made a haiku generator. Yeah, generated haikus. The grammar was a bit off, but like not all of that, but some of the haikus that spat out was better than this, and that was just random bullshit. Right, now recall the little program we wrote when we were introducing the forever function. I don't remember that, that was ages ago. It prompted the user for a line, returned it to him in caps lock. Oh, right. No, I remember this. And we did that all over again indefinitely. Just so you don't have to scroll all the way back, here it is again. Thank you. It was a control monad where we took forever. Right, I remember this because I was thinking, why not just do this recursively, right? Why not just add an extra line and just call main? Feels like redundant to import this control monad for something that we could just... But I don't know, there's probably some useful stuff to think about it, right? There's probably other control stuff we want to do with the control monad whenever we learn about that. And using forever is just an easy way to do things, I guess. Data.char, give me some input, then we get the line. And then we make them all to upper. Yeah, the line. Oh yeah, I am tired today. We'll save that program as capslocker.hs or something and compile it. And then we're going to use a Unix pipe to feed our text file directly to our little program. Wait, we'll get line, get the pipe. All right. Unix pipe to feed our text file directly to our little program. We're going to use the help of the GNU cat program. Great program, yeah. Read a text about cat recently, which prints out a file that is given to it as an argument. Check it out. Booyah! Right. First, we compile this program. Make the caps locker. Right. We've compiling. We've linked it, and then we're gonna cat the text file. Oh yeah, we're gonna cat the text file. That is just printing it, pretty much. We print all the contents of the text file, and this is the great haiku again. Almost as good as lolcat. I don't know about that. I've actually never... I think I never installed lolcat. I mean, I've seen it, but I never installed it and did it myself. Right, and then we take this, because this is the output of this command, gives you this output in Linux or Unixy environments. Right, and what we do is that we pipe it. So instead of printing it, which this does, we use this pipe thing, is that we take this, instead of just making it into output, we use it as input in our caps locker thing. And it works. Get line takes our piped, uses this as, yeah, it gets these lines. And it works in a lazy manner. And since we just do it to upper, we capitalized everything. Oh, and then we get a... what is this? Caps locker, standard input. Oh, end of file. Yeah, exactly. Oh, wait. I'm assuming, though, that since we have the forever thing, we did get to the end of file, but then we got an empty line, right? Because we can start printing our own lines after this if we wanted to. As you can see, piping the output of one program, in our case, that was cat, was the program, to the input of another, which is our caps locker program, is done with the pipe character. What we've done is pretty much equivalent to just running caps locker, typing out our haiku in the terminal, and then issuing an end of file character. That's usually done by pressing Ctrl D. Oh, that I didn't know. Usually, I don't do end of file characters. I usually just do Ctrl C to get out of programs. That's good to know. Ctrl D. Program wants the D. That's it. It's like running cat haiku.txt and saying, wait, don't print this to the terminal. Tell it to caps locker instead. Exactly. So what we're essentially doing with that use of forever is taking the input and transforming it into some output. That's why we can use getContents to make our program even shorter and better. Import data.char, main do, contents is getContents, and then we just put them to string. Right, and we map that to our contents. Yeah. Yeah, this is looking pretty good. We run the getContents IO action and name the string it produces contents. Right, yeah. This is an IO action. This is the string that we've taken out of this box. Yeah. Then we map to upper over that string and print it to the terminal. Keep in mind that because strings are basically lists, which are lazy, and getContents is IO lazy, it won't try to read the whole content at once and store it into memory before printing out the caps locked version. Rather, it will print out the caps locked version as it reads it, because it will only read a line from the input when it really needs to. Laziness. And there we have it. Cool, it works. What if we just run caps locker and try to type the lines ourselves? Hey-ho, let's go. Yeah, exactly, because this is the input and this is the output. This is the content we get and this is the content we print out. We got out of that by pressing Control D. That's pretty nice. Or Control C. That's pretty nice. As you can see, it prints out our caps locked input back to us line by line. When the result of get contents is bound to contents, it's not represented in memory as a real string, but it's more like a promise that it will produce the string eventually. When we map to upper over contents, that is also a promise to map that function over the eventual contents. I gotta say, I'm really happy that I heard about linked lists and like saw some YouTube videos on it before learning about Haskell and understanding that rather than data structures like in the other languages that I've been used before, the lists have been, yeah, static. You put it in memory, right? But since we do a lazy language, a linked list is the way to go. That's why, of course, in Haskell, a list is a linked list from the get-go, because that's how you do lazy evaluation. But lazy is not specifically for functional programming, right? That you can have a lazy imperative language, can't you? I don't remember. It's not really relevant to the current discussion, I suppose, but it's just a friendly reminder that these lists, when we get a list in Haskell, it's not the same as a list in Python or C or whatever. A linked list, if you want to look into it further. Similar to the tree structure we did weeks ago, I don't remember. When we map to upper over contents, that's also a promise to map that function over the eventual contents. And finally, when we do the put string thing happens, then I need a caps lock line. It doesn't have any lines yet, so it says to the contents, hey, how about actually getting a line from the terminal? So that's when get contents actually reads from the terminal and gives it a line to the code that asked to produce something tangible. That code then maps to upper over that line and gives it to put string, which prints it. Then put string says, hey, I need the next line, come on, and this repeats until there is no more input, which is signified by the end of file character. Oh, is that? Right. Right, let's make a program that takes some input and prints out only those lines that are shorter than 10 characters. Observe. Right. Main do contents is we get our contents from wherever, right? And we put string short lines only contents. Yeah, exactly. We take this function. Yeah, this is what we print. The function of the contents. And this takes a string and returns a string where we do a let. Oh, I haven't done those at all. My helper functions, I've been separating them out instead of defining them within our functions. I've been separating them out, right? I would have just put all lines outside of this function. That's just for my own It's easier for me to separate it all out instead of looking at this entire thing all at once. Alright, so let all lines be lines input. That is all the lines, I guess. ColgateNoTab says you used to use where bindings. Yeah, I did that for a bit, right? And I probably will go back to it later. It feels like such a, yeah, just like the let functions. I will probably get into that later, but for now it feels good to take a step back and just separate all the functions. Because in my mind, I like to think about that the specific function we're doing right now and what that is supposed to be. Right, so all lines, for example, that's lines of input. Right, because we have a string and we turn it into a list of strings. Each line is short lines, and then we filter if our line we filter if our line length is greater than 10. That's what we filter. I'm always confused by this. We filter them out if they're greater than 10, or we keep them if we keep the lines if they're smaller than 10. Yeah, we don't filter out, we keep stuff in. Yeah, filter them in, exactly. And we do that with all lines, and result is right. We don't want to have the list of strings anymore. We want just one long string. That's the result. Wait. And unlined short lines. In result, wait, that is confusing. Let all of these be in result, but that last part I don't get. I guess we'll get to it. He will explain. The author will explain. We've made our I/O part of the program as short as possible. Yeah, because our program is supposed to take some input and print out some output based on the input, we can implement it by reading the input contents, running a function on them, and then printing out what the function gave back. Yeah. Input, output. That's the I/O part of the program, so just keep that short because it's tainted. ColgateNoTab says it is like you had a result where... Right. All right. Result is equal to this, where all lines are lines input and short line. But this... Oh, right, because the where thing works on result, I guess. Yeah, because we have short lines. Yeah, that's where we go. But it's weird. That is where it confuses me, because it makes sense that all lines are short lines, all lines, that makes sense. But to me, this line shouldn't be here, and it should said in this. No, we have to define the function. It's confusing. Because our program is to take some input. Yeah. The short lines only function works like this. It takes a string like short long, short again. That string has 3 lines, 2 of them are short and the middle one is long. It runs lines function on that string, which converts it to a list of strings. Short, long, short again. Exactly. We'll get in on tab says in unlines, short lines. Yeah, exactly, right? The result seems unnecessary and confusing. There might be a reason for it. We'll get to it. I mean, that's the Haskell journey in general. Everything is confusing all the time. Right, which we then bind to the name all lines. Bind. Okay. That list of strings is then filtered so that only the lines that are shorter than 10 characters remain in the list, producing short, short again, and finally unlines joins that list into a single new line delimited string given short. Yeah, exactly. Let's give it a go. All right. This is the input, this is the output. Yeah, we pipe the contents to shortlines.txt into the output of short lines only, and as the output we only get the short lines. Oh, he actually didn't mention this at all. Yeah, I feel like just like the last time when we saw this syntax, I was like, I like the where syntax better. And I still do, yeah. Long man. Right, yeah. I remember that. Fucking ads. It's quite funny though. Even though I have a general distaste for ads. Quite funny series of ads, I suppose. Right, this pattern of getting this pattern of getting some string from the input, transforming it with a function, and then outputting it is so common that there exists a function which makes that even easier, called interact. Interact takes a function of type string to string as a parameter and returns an IO action that will take some input, run that function on it, and then print out the function's result. Let's modify our program to use that. All right. Main. Interact. Short lines only. Just abstract everything away, eh? I feel like that's the Haskell way of doing things. Just abstract everything away. I need to get used to that. I mean, we have talked about it before, and I have found the arguments compelling to why you would abstract everything away, but at the same time, there's so many names of things to keep track of, and I'm terrible with names. I'm just terrible with names. So we interact with short lines only. Short lines only takes a string and returns a string. And oh yeah, it's this function is still the same. Just interact. We'll get in on tab says that one-liner is how Code Wars' best answer would do it. This one-liner? Yeah. Of course, this would be the best way in Code Wars. Right. Just to show that this can be achieved in much less code, even though it will be less readable, and demonstrate our function composition skill, we're going to rework that a bit further. Main interact unlines filter. That's the right. Those two, right? Length. Oh man. Less than 10. Length is less than 10. Oh wow, yeah. This is... That's what I was just saying, right? Abstract everything away. Oh man, I have no composition skill yet, but... This would definitely be the best Code Wars answer, and this is the goal, right? To understand this and be able to do this. Isn't function composition cool? It is very cool. I mean, this is very cool. It's just super fucking cool, but it's also all abstracted away. There's so much stuff going on that you have to have in your head with you, right? So this is good for learning this. This is a stepping stone to get here, I suppose. But when you actually get here, this is probably kind of great, I assume. Well, we actually reduced that to just one line, which is pretty cool. It is. It is cool. Interact can be used to make programs that are piped some contents into them and then dump out the result, or it can be used to make programs that appear to take a line of inputs from the user and give back some result based on that line, and then take another line and so on. I kind of like interact. There isn't actually a real distinction between the two, it just depends on how the user is supposed to use them. Yeah, you can pipe in or you can just give input. I kind of like that, how the get input works in Haskell, that it takes standard input or it takes written input, right? Right. Let's make a program that continuously reads a line and then tells us if the line is a palindrome or not. We could just use getLine to read a line, tell the user if it's a palindrome, and then run main all over again. But it is simpler if we use interact. When using interact, think about what you need to do to transform some input into the desired output. In our case, we have to replace each line of the input with either palindrome or not palindrome. Right. We have to write a function that transforms something like elephant or whatever into not a palindrome, wait, not a palindrome. Oh, right. I get it now. Yeah, this is not a palindrome, this is a palindrome, this is not a palindrome. Yeah, this doesn't seem too difficult, is it? Yeah, exactly, palindrome. You just reverse the list, right? Reverse and compare. Right, respond palindromes contents. Wait. Respond palindromes contents. Contents we get from interact, right? That's where we get our contents from? Yeah. Unlines. Wait. That's a mistake I often do. I start reading from the start of the list. That's not really how you do it. The easiest way, if you try to read it imperatively, or I think the easiest way to read it is from the innermost parentheses and then go outside. Yeah, starts from the inner and go out, rather from starting from the outside and go in. That's got to be easier, right? We have our lambda function here. I'm assuming this just... Yeah, this is our lambda function, which says if it is a palindrome, if our list is a palindrome, then we have this string. If it's not, then it's not a palindrome. And we map this function on the lines of our contents. So for each line in our content, we will test if it is a palindrome or not. And here we have our helper function that we use within our lambda function. We use our helper function that just takes a list, reverses the list, and checks if they are the same. So we write this function, and then we just do main interact respond palindromes, and that's it. That's our main. This is our function, I assume. Let's write this in point free. What is point free? I forget. Oh, without the contents. That's the point free, so we remove this, and we don't need this because on lines and map can be the non-Lisp way, exactly. They can be compositioned. I still have a little bit of problems with removing contents. I don't know if I'm happy with that. I'm happy with removing parentheses, right? The non-Lisp way. Well, I like removing contents, but it's also... It's like I said before, right? The goal is to get here. The goal is to remove contents. So I like the way that the text is doing, right? First showing us with the contents, and then showing us without. Because that is where we're trying to... That's the goal. That's the cool Haskell programmer, I suppose. Doing it this way. A non-Lisp way, yeah. Right, onlines map. Oh, look at that. We even remove contents, right? Oh man, I would not be confident at all to remove contents from here, right? Because in here we're all up in this parentheses going on. But when we remove this parentheses, then it's only lines contents. And since, yeah, we can put the dot there. I would definitely have put a $sign here rather than a dot. Yeah, I think I will probably start overusing the $signs like crazy and don't use the dot thing because I'm confused how that works. Yeah, it comes with practice. Exactly, it comes with practice. No practice today, though. Hopefully practice tomorrow. Pretty straightforward. First, it turns something like this into elephant. Yeah, it turns the elephant into a list of strings with lines. And then it maps the lambda over it, giving not a palindrome, palindrome, not a palindrome. And then unlines that joins them to a new line delimited string. And now we can do main interact. Yeah, exactly. This is our main function, main IO. Yeah, this is our main IO function. Action. Interact is an action. Main is a function. Main is the main function. And interact is the IO function. Yeah. There we go. So let's test it out. Yeah, and it works. Even though we made a program that transforms one big string of input into another, it acts like we made a program that does it line by line. That's because Haskell is lazy and it wants to print the first line of the result string, but it can't because it doesn't have the first line of the input yet. So as soon as we give it the first line of input, it prints out the first line of the output. We get out of the program by issuing an end of line character. Right. This is not what you want, right? When you do input-output with pipes, right? We cannot pipe not a palindrome when it's interactive like that. But we can, however, if we had a file with hey ABCBA and cookie, then actually, yeah, if we just took the string and piped the string into our program, then we could take the result of our palindromes thing and pipe that further, right? So you probably want some kind of setup, and I'm assuming that's gonna happen, where we do run Haskell palindromes HS, and then after here we give an argument. Like we just write hey, and it returns just not a palindrome, and then, oops, sorry about that, and then we're finished. Right. We can also use this program just by piping a file into it. Let's say we have this file. Boom. Yeah, exactly. And we save it at words text. We can pipe it into our program. Not a palindrome, palindrome, palindrome. Yeah, exactly. Again, we get the same output as if we had run our program and put in the words ourselves as at the standard input. We just don't see the input at palindrome.hs because the input came from the file and not from us typing the words in. Exactly. It's for the program, this is the same. It's just we don't see them because we did not type them out. We typed them out in here. We do see them, kinda. They're just hidden away in a file. So now you probably see how lazy I/O works and how we can use it to our advantage. That we can indeed. You can just think in terms of what the output is supposed to be for some given input and write a function to do that transformation. In lazy I/O, nothing is eaten from the input until it absolutely has to be, because what we want to print right now depends on that input. Right, so far we've worked with I/O by printing out stuff to the terminal and reading from it. But what about reading and writing files? Well, in a way, we've already been doing that. Yeah, we can just, since we're Linux user or Unix users, right, we can just take the output and, like I said, we can just add this to a file. Right, we can just add, right, if we do that, do this, we could just do that. I think that's the way you do it. Or do you? No, I think this is fine, right? I don't remember, but it's fairly easy to write that all to a file if we want to. All right. Well, in a way, we've been doing that. One way to think about reading from the terminal is to imagine that it is reading from a somewhat special file. Yeah. In Unix, well, in Linux, I assume the rest of Unix as well, everything is a file. Same goes for writing to the terminal. It's kind of like writing to a file. We can call these two files standard in, standard out, and standard in. Yep, meaning standard output and standard input, respectively. Keeping that in mind, we'll see that writing and reading from files is very much like writing to the standard output and reading from the standard input. We'll start off with a really simple program that opens a file called girlfriend.txt, which contains a verse from Avril Lavigne's #1 hit, Girlfriend, and just prints out to terminal. Here's the text. Hey, you, I don't like your girlfriend. No way. I think you need a new one. Wow, that's one way of looking at it, yeah. I'm just a little bit curious here because it's starting to get to lunchtime, so it is definitely lunchtime, and this feels like a good spot. Right, we went through just standard input, standard output, right? Now we're going to working with actual file printing, well, writing 2 files, I guess, from within Haskell. So yeah, that's a good spot for lunch, and probably continue reading this the day after tomorrow. Probably. So yeah, thanks for hanging out, and have a good one. Yeah, cheers.